In Part 1, we compared the concepts. In this video, we'll walk through the actual code and understand how LangGraph and Google ADK differ in design. Puzzle mark, what you're seeing. This comparison shows the same idea implemented in two different ways. On the left, LangGraph uses an explicit graph and state model. On the right, Google ADK uses an autonomous agent abstraction. Both are valid, they just make different design choices. Next, LangGraph code explained. Let's start with LangGraph. First, we define a shared state, messages, and next step. This makes data flow explicit and trackable. Then we define nodes, in this case, an agent node and a tool node. The agent uses an LLM to decide whether to respond or call a tool. Finally, we define routing logic. If the model requests a tool, go to the tool node. Otherwise, end. So in LangGraph, flow is explicit. Transitions are defined by the developer, and the system behaves like a state machine. Next, Google ADK code explained. Now let's look at Google ADK. We start by defining a tool, same concept as before. Then we create an agent, assign a model, attach tools, provide instructions. When we run the agent, the framework handles tool selection, reasoning, and execution flow. So in ADK, flow is implicit. The agent decides what to do, and orchestration is handled internally. Key difference. The main difference is not capability. It's where orchestration happens. LangGraph. Orchestration is defined in code. Google ADK. Orchestration is handled by the agent runtime. Both approaches can achieve similar outcomes. Trade-offs. Each approach has trade-offs. LangGraph. More explicit structure. Easier to inspect execution flow. Requires more setup. Google ADK. Less boilerplate. Faster to get started. Less visibility into intermediate steps. Neither is inherently better. It depends on what you need. A-to-A capability. Google ADK also introduces agent-to-agent communication. This allows agents to discover and interact with each other dynamically. LangGraph doesn't emphasize this pattern directly, but similar systems can be built with explicit coordination. In practice, some teams prefer explicit control and structured workflows. Others prefer abstraction and faster iteration. These are different engineering philosophies, not competing features.